Greetings, my name is Sophia Guzman. Today I will be talking about MATLAB and RoboDK. The objectives for this video is to create a homogeneous transform matrix for a z, y, x Euler angles, and to also create a program using RoboDK. In MATLAB, I created a function to calculate the homogeneous transform matrix using the zy Euler angles. This code takes in three inputs like alpha, beta, and gamma. The rotations will be a 3x3 rotation matrix, which represent the rotation about z, y, and x axis with a position vector, which will be a 3x1 position vector. We'll be also talking about the two cases, which we will be plugging in the angles to see how MATLAB calculates these matrices once these angles are inserted. We will also see the RoboDK, which will be using a 6-axis robotic arm with an added spray painter tool. The program is using key positions like home, approach, spray path, and retraction. So let's start with our codes. So in MATLAB, here is where I present my code. This is my function, the T with earlier ZYX transform. We'll be using alpha, beta, gamma, P. Here is where I establish my rotation matrix for Z. MATLAB uses the the radians, and to convert the radians to degree instead of defining or changing this radian to degrees, I opted by using the functions already used in MATLAB, for example, CoSD, which the CoSD will automatically convert the radians to degree. So here in the Z rotation, we have the code D for alpha, negative, C and D alpha, and 0. This is for the first row, the second row, and the third row. Same continues with the Y rotation and the X rotation. Here we have the resultant of the matrix multiplications. And here we have the homogeneous transformation. We have the rotation, the vector, and what it makes the homogeneous transformation is right here. The transformation will end up being a 4x4. Since the code is established with its rotation in the test run, I establish my angles. Here is alpha, beta, gamma with the vector of 1, 2, 3 for the first case. For the second case is an angle of 0, 20, and 0 with a vector of 3, 0, 1. Here, this T1 is establishing to display the answer as well as the display of T2. So I'm gonna make sure to close this tab. So right here, we can see that our command window is cleared. So the results is easy to see. I will run the program. That was fast. So this is the answers for T1. It's displayed 2 times, as well as T2. It's a 4x4, as I explained, homogeneous transformation. It has 4 rows and 4 columns. Now, I am going to use the zip code provided by the professor to see if these results concur. So let me first going rapid. I believe the downloads. Okay, over here. And this is our file. Over here, we can see the zip code with its code. This is the code from Peter Court. I am gonna run this code to see if it concurs with my answers. I plugged in the code, give it a time. And there you have it. Whoopsie. The T1, oops, the T1 and T2 over here, T1, T2. So we can say that our answer is correct. Now we'll continue on with the RoboDK program. So first, I was able to look for the robotic arm in the RoboDK library. To establish the position, it's very easy. You can move the axis with the degrees. Here. And if you are satisfied with its position, you can target the position just by pressing the target. Let's see what happens. And this is the target. The target programs the degrees. So if I change, let's say, let's just move the base. And I want it where I targeted, in this example is target A. It will move back as it was established. I am going to delete this because I don't need this. I have 7 targets in total for 2 programs. And the first program is by following a directional video on how to use the RoboDK. First, let's see our home position, our approach, how the arm retracts, and this is our paths established. And I was able to program these targeted angles by pressing the program. And if I want to run the program, I just can press here and you will be able to see how the program runs. And back to home. I would actually improve the movements just by this new approach being the start position for me for my second program. This is how I will change and make the program better. So if I start by home, just so you can see how the program runs. The programs will start off with home, the new approach, the circular movements between 2 and 3, and back to home. So let's see. And this is how I would use the robotic arm. It's a one process less. Over here is 1, 2, 3, 4, 5, 6 processes. Oh, this is a 5 process. So in this video, we were able to use MATLAB to calculate 2 homogeneous transformations, as well as the use of RoboDK with the use of a robotic arm, which is a 6-axis with an additional spray. And thank you for your attention.